Okay, so I don't know much about electricity, but I don't necessarily have to know it to solve this problem, right? Because if I follow the units that they've given me, they say that this columns is C. That's the units. Okay, and then they say I of t is measured in amperes. Somebody's gonna make fun of me for my pronunciation, but and that's the derivative of that's C over S. So that's the change in one variable with respect to another variable. That's a slope. Okay, um, where S is seconds. So the notation's a bit confusing because we have t for time. You could replace this with seconds and that'd be fine. So what we found out from that notation is that this is the derivative of of whatever Coulomb's function is or whatever those units are. So to find how much charge passes through after 8 seconds, then we need to find out from 0 to 8. It's just like with the integral from 0 to 8. It's just like with those problems when you're given velocity and you're told to find out how far the object has been displaced, how far it's changed in location, then you need to take an integral because the integral of velocity is location. Same thing here. The integral of I is C. So it's not that bad of an integral. Just using the power rule in reverse. So the antiderivative here is 3t to the third, because if you take a derivative, the 3 comes down and multiplies and gets reduced by 1. And then here the antiderivative would be t squared, because if you take a derivative, the 2 comes down and multiplies and gets reduced by 1. And then this is 3t. So from 0 to 8. So if you plug in the upper limit of integration, that's 8 to the third times 3, so that's 1536 plus 8 squared, that's 64, plus 8 times 3, it's 24, and then we would subtract what happens when we plug in 0. So final answer here, I got 1624.